Okay, so this is the key to section 4.3 part 2, and so basically you're going to be expanding these logarithms. And so if you look at number 1, we have the log base b of y to the 7th times x. So notice I'm going to be using the product property and the power rule, the power property. All right, but you can't do the power first because this whole thing's not being raised to the 7th power. It's only being raised to the 1st power. So the only thing being raised to the 7th is y. So don't pull the 7 out in front. If you pull the 7 out in front, what that means is that x was also being raised to the 7th power, and it's not. So you got to be careful. So you got to use the product property first. So the product property, remember the product property said this: the log of m n with some base is the log of m base b plus the log of n base b. And so this becomes a log base b of y to the 7th plus the log base b of x. Now I can use the power property here. So remember the power property said the log base b of m to the n is now, so whenever you're taking the log of some argument raised to a power, the whole thing raised to that power, then you can take that power and rewrite as a product. So it'll be n times the log of m base b. So then this becomes 7 times the log base b of y plus the log base b of x. So that's the answer to number 1. So 7 log base b of y plus log base b of x. Okay, number 2, you have log base b3 of x to the 4th divided by y cubed. So again, this time you use the quotient and the power. So remember the quotient was this. So log base b of m divided by n, you write as a difference. So it'll be the log of the numerator with the base b minus the log of the denominator with the base b. So this becomes log base 3 of x to the 4th minus the log base 3 of y to the 3rd. And then you use the power property. So you can take the 4, pull out in front, take the 3, pull out in front, and you get 4 log base 3 of x minus 3 log base 3 of y. And so that's your answer there. So number 2, the answer is 4 log base 3 of x minus 3 log base 3 of y. Okay, number 3, you have the log base 2 of 8x cubed. So again, do not pull the 3 out in front, because if you do, you're implying that 8 was raised to the 3rd power also, and it's not. So you got to use the product first. So that's the log base 2 of 8 plus the log base 2 of x cubed. And then notice I can simplify this, because remember part of the direction says evaluate log expressions without using a calculator. So remember, log base 2 of 8 means 2 to what power is 8? So the answer is 3. Log base 2 of 8 means 2 to what power is 8? So that's a 3 here. And then now I can use a power here, so that becomes 3 plus 3 log base 2 of x. So the answer number 3, so 3 plus 3 log base 2 of x. Number 4, you have log base 4 of 16x to the 2/3. Log base 4 of 16x to the 2/3. So that becomes, again, you use a product first and then the power. So it becomes the log of base 4 of 16 plus the log base 4 of x to the 2/3. Now right here, I can simplify this. 4 to what power is 16? So remember, 4 log base 4 of 16, 4 to what power is 16. So when I change this to an exponential, I get 4 to what power is the argument. So 4 squared is 16. So this is 2 here. And then I can use the power here. So that becomes 2 plus 2/3 log base 4 of x. All right, so that was number 4. So 2 plus 2/3 log base 4 of x. All right, number 5, you have log base 6 of the square root of x divided by 36. Now you need to rewrite the square root of x. You have to rewrite that. So remember, the square root of x is x to the 1/2 power. So you can always write a radical as a rational exponent, rational expression. Alright, so now I'm going to rewrite this. So it'll be log base 6 of x to the 1/2 divided by 36. Okay, so again, you don't pull the 1/2 in front because that would mean that 36 was also raised to the 1/2 power, and it's not. Only the x is. So use the quotient first. So that's log base 6 of x to the 1/2 minus the log base 6 of 36. So now I can use the power here, and then log base 6 of 36, I can figure out what that is. So changing this to an exponential, this becomes 6 to what power is 36. So 6 squared is 36, so that's a 2 here. So that becomes 1/2 log base 6 of x minus 2. So that's number 5. Number 5 is going to be 1/2 log base 6 of x minus 2. Okay, number 6, you have log base b of x to the 4th y squared divided by z cubed. So log base b of x to the 4th y squared divided by z cubed. So notice this time I'm going to use all three. I'm going to use the power, I'm going to use the product, I'm going to use the quotient. But so you can't use the power first because not all of these are raised to the same power. They're not all raised to the 4th, they're not all raised to the 2nd, not all raised to the 3rd. In fact, its argument is raised to the first power. And then you got to use the quotient first, so the quotient will take precedence over the product. So I'm going to get the log base b of x to the 4th y squared minus the log base b of z cubed. So that's what it looks like. So log of the numerator minus the log of the denominator. Now again, I got to use the product here before I use the power. So it'll be the log base b of x to the 4th plus the log base b of y squared. So that's what this becomes. So I use the power of the product here. Minus, I'm just going to rewrite this over. So now in each of these cases, I can use the power. So I'm going to pull this 4 out in front, pull the 2 out in front, pull the 3 out in front. And so this becomes log 4 log base b of x plus 2 log base b of y minus 3 log base b of z. That's a z. And so there's your answer. You can't do anything else. So the answer then would be 4 log base b of x plus 2 log base b of y minus 3 log base b of z. Okay, number 7, you have this now. Number 7, you have log of x divided by yz. Log of x divided by yz. So again, I'm going to use the quotient and the product. So I'm going to do the quotient first. So there's no power property here. So it becomes a log of x minus a log of yz. Okay, now notice when I did number 6, I did the product. The product was listed in front of the subtraction, so that was not going to be an issue. Here, though, I got to be careful because remember this. I'm taking the log of a product, so I'm going to have to write this as an addition problem. But you're subtracting this, so you're subtracting this log. So you got to subtract. Remember, we're going to write this as 2 terms. So you got to subtract both terms. So remember when we talked about this in previous lessons, you really need to put this in parentheses. You have to put this in parentheses. So it becomes a log of x minus, in parentheses, now put the sum because you're subtracting each of those terms. So the log of y plus the log of z. And now distribute, I get the log of x minus the log of y minus the log of z. And so that's the answer there. So that's how it looks. So if you had not put the parentheses there, you would have probably said the log of x minus the log of y plus the log of z, and that's incorrect. So be careful. You need parentheses when you subtract. So that's going to be the log of x minus the log of y minus the log of z. Okay, number 8. All right, number 8, we have the log of 2x cubed. Log of 2x cubed. So again, when there's no base, it's understood to be 10, so that's common logarithm. Now this time I can use the power first. I need to use the power first because both 2x are being raised to the 3rd power, so that's a 3. So it becomes 3 log of 2x. Now I'm going to use the product here. Now be careful, this whole thing is being multiplied by 3. So if you think about this, this is really 3 times, remember, using the product here. So I want you to notice why I'm putting this in parentheses. So that's a log of 2 plus a log of x. So remember, all of these, when I expand this, all of these terms have to be multiplied by 3, so you've got to be careful. So if you weren't careful, you probably would have said 3 log 2 plus log x, and it should have been 3 log x. So be careful. So you got to, when you expand it as two terms, remember you're multiplying by 3. Just like a while ago, we said that when you expand this in two terms, you're subtracting both of those. So here, when you expand it, you're multiplying both of those by 3. Same idea. Okay, so in number 8, the answer is going to be 3 log 2 plus 3 log x. All right, number 9, you have the natural log of 3 to the e squared. So again, I can use the power first. So that becomes 2 natural log of 3e. And I'm going to use the product. Now, just like this one, I'm going to expand it first and then put that in parentheses. So that's 2 times the natural log of 3 plus the natural log of e. So that's what it becomes. So 3 natural log of e is natural log of 3 plus the natural log of 3 is the natural log of 3 plus the natural log of e. Now remember, the natural log of e, I can simplify this. So remember, the ln is really log base e. So that's this. And so this becomes e to what power? So when I change an exponential, so e to what power is e? So e to the first power is e, so that's 1. So I'm going to rewrite this as 2 times the natural log of 3 plus 1. And now distribute, I get 2 natural log of 3 plus 2 times 1 is 2. Okay, that's your answer. So again, you got to make sure you simplify this, because the direction says evaluate without using the calculator. Right, so the answer is 2 natural log of 3 plus 2. All right, and then finally number 10, you have the natural log of e divided by x raised to the 5th power. So again, I'm going to use the power first, because all this quotient is being raised to the 5th power. So use the power first. That's 5 natural log of e divided by x. So I'm going to expand this, so that's a quotient. I'm going to use the quotient property, so I'm going to change that to a subtraction problem. So that's 5 times the natural log of e minus the natural log of x. All right, so 5 times the natural log of e minus the natural log of x. And so remember, the natural log of e we just found was 1. So I'm going to replace this with 5 times 1 minus the natural log of x. And then distributing, the answer becomes 5 minus 5 natural log of x. 5 times 1 is 5, and 5 times the negative natural log of x is negative 5 natural log of x. And so there's your answer there. So that was number 10. So number 10 is 5 minus 5 natural log of x. Okay, so that takes care of the key to section 4.3, part 2.